Let's continue now with class 14, which is bivariate analysis. This is from topic 5 of the IB Mathematics standard level from the guide. Bivariate analysis, from its name, is analysis we have to analyze, and bivariate, bi is two and variate is from the word variable. So we're having two variables, and like we're gonna analyze what's happening between these two variables, the relationship, if one variable increases, what happens to another. We'll take some examples, and it's not of a hard topic, but it's really essential. If we're gonna start by, let's say we're having, let's talk about the scatter plot. The scatter plot, you have a bunch of coordinates scattered, and you're gonna see what the relationship is between them. Let's say I'm having on the x-axis, I'm having the numbers of our work by employees. This is the hours, let's say daily. And I'm having on the y-axis the income, either daily or monthly. It does not make a big difference. And I've made a survey, and I've gathered the data for several employees for how much do they work, and I end up with my data is something like this. So I'm having an x value and a y value for each point or each coordinate, and I want to find a pattern between these data points. So simply, if I wanted to draw a line which passes through the majority of these points, or makes the points above the same as points below the line, I have to draw what's called by the line of the best fit. The line of the best fit is the line I described. It is the line that passes through the majority of our scattered points. Like if I want to draw this line, let's say this is my line of best fit. The most important thing, my line of best fit must pass through the mean point of all of these points. This is the mean point. This mean point is x bar with y bar. Now, to see a relationship between two variables, either they are negatively correlated or positively correlated. When I say positively correlated, I mean if I'm having two variables and I'm having a positive correlation between these two variables, let's say I'm having an x and y. A positive correlation, it means as x increases, the value of y increases. This is a positive correlation. If I'm having a negative correlation between these two variables, a negative correlation, this means as x increases, the value of y decreases. And what we'll be caring about here is the Pearson product moment correlation coefficient. The Pearson product moment correlation coefficient, which is R. R is a value that lies between 1 and -1. If R is equal to 1, then it's a perfect positive correlation between the variables. I'm having the scatter plot to form a straight line. Here my scatter plot will be forming a straight line when r is 1. So by drawing my axis, let's move it a bit. All my points will be forming a straight line of my scatter plot. So let's draw our line. This is a perfect line. In this case, the value of my r is equal to +1. When all the points form a perfect straight line. But it's a +1 because I'm having the gradient to be positive. If I'm forming a perfect straight line, like this, draw the axis first. And this is my perfect straight line. Sorry. Just erase it. I want a straight line. And I can find here that all the points lie on this line. Then there is also a perfect but negative correlation. Oh, here my r is equal to -1. This is the value of my r. Let's explain how my values of r changes and how can I know what my value of r is. Let's draw many samples. We have let's say my points are this way. I have to divide this area into 4 quadrants. So after division of the quadrants, I'm having these are my quadrants. This is my first quadrant, this is the second, this is the third, and this is the fourth. If you can see that the points are somehow equally distributed among the quadrants. In this case, I have no correlation. This case gives me no correlation. No correlation, the R value is something around this 0, either from the negative part or from the positive part. Let's see when I'm having a positive correlation. Let's draw our axis first. Let's draw our points. These are my points. And let's make our quadrants. It's from the half of these points. If you can see, here I'm having all the points lying in the first and in the third quadrant. In this case, when all the points, the majority of the points are found in the first and the third quadrant, then I'm having a positive correlation. And most of the time, the positive correlation, the value of R, of course, is a positive, will be greater than 0.6 and less than the 1, because it's not a perfect positive correlation. Otherwise, it will be a 1. This is for the positive correlation. Let's see the negative correlation now. For our negative correlation, let's draw our axis. My points will be like this. If I draw my quadrants, we'll find that most of the points lie in the second and the fourth quadrant, which means I'm having a negative correlation. Negative correlation means as the value of x changes, increases, the value of y decreases, is a negative correlation. So the value of R would be either less than negative 0.6, so R is less than negative 0.6 and greater than negative 1. But it's not a negative 1 because it's not a perfect negative correlation. It's not a perfect negative correlation. Now, after we discuss the correlation, when we draw our line of best fit, we must be capable of finding the equation of this line. We call it line of regression. Let's take an example. Let's see what's actually happening. My axes, these are my axes. Let's plot some points. These are my points, and I want to draw my line of best fit. This is my line of best fit. This line, from its name, is a line. So I'm finding an equation of line. That's why I call it linear regression. Linear regression. And the ways to find the equation of this line, simply I need to have any 2 points to find my equation of straight line, as you can remember from class 1. As we've discussed, finding the equation of straight line. But here the regression, we can do it using our graphical display calculators. So the equation of this line is in the form y equals ax plus b, where a and b are constants to be found. What's the purpose of finding the line of best fit is for prediction purposes. It's like I'm having set of points, set of data points, and to predict or to know what's coming in the future, I need to do this linear regression in order to find values I'm expecting to have. Is like if we want to get back to our example of hours working with the income. Let's say I'm having all the data for the hours working of 12 hours. And I want to know if someone works 14 hours, what will be his income? So his income or her income will be somewhere here. So this point, I can find it using my line of regression. simply I substitute the 14 instead of the x, and I can't find my value of y. So linear regression and finding the line of best fit is for prediction purposes or for model creation. If I want to create a model joining two variables, I need linear regression. You don't have in your examinations exactly don't to worry about finding the line of best fit because your GDC do all the work. But sometimes in your internal assessment, you need to know how to use the least squares, the sum of least squares method to find your best model. Now, that's simple. We found the value of R and we found our line of regression. Let's solve a question from the question bank. Let's go. This question, we have a table for the weights corresponding to heights of men. This is the height, my x value, and my weights are the y. Part AI, the relationship between the variables is modeled by the regression equation y equals ax plus b. Ax plus b, which is a linear regression. Write down the value of a and b. Okay. Now, we have to use our GDC. Let's start it. We go to stat. We have the edit here. We press the enter because we need to fill the lists. To fill the lists, we fill the x variable in the first list and the y variable in the second list. So let's fill our first list in 165, 170, 175, 180, and 185. This is my first list. Let's fill the second list, which is the y, 67.8, 70.0, 72, and finally 77.2. Now we've filled the list. We need to find the equation of the line of regression joining these two variables. So we go to stat, we do calc, and we go to number 4, which is linear regression in the form ax plus b, and we press the enter. Now, my first variable is in list 1, so I list 1 and a comma, and my second variable, which is in list 2. And we press enter again. So I have my linear regression, y equals ax plus b. The value of a is 0.486. A is equal to 0.486. Let's write it here. A is equal to 0.486. And the value of b is minus 12.41. Minus 12.41, leading to the equation y equals 0.486x minus 12.41. This is my line of regression. This is the equation of my line of regression. Part A, section II, the relationship between the variables is modeled by this line, which we found it. Hence, estimate the weight of a man whose weight is 172 centimeters. You can see our line, we found the line for production purposes. Because we don't have the data of a man who has a height 172 to know his weight. So we needed our line. So to find the height of a man the weight of a man whose height is 172, we need to plug in this value instead of the x in our equation. So y is equal, which is the weight, 0.486 times 172 minus the 12.41, which is equal to 'cause I need to put it in kilograms, which is equal to, let's find it using our GDC, clear, 0.486 172 12.41. So the weight, the three significant figures, is 71.2 kilograms. 71.2 kilograms. This is my estimated weight. Now, part BI, we need to write down the correlation coefficient. Here, my linear regression, my value didn't give me the correlation coefficient. I having the lists. Then when I go to stat, calc, linear regression, it must automatically give me my correlation coefficient. Why it didn't give me that value? Because I'm not having the diagnostics on. So I go to mod, and here find my diagnostics. I need to find it on. Let me continue with you. I'm using my own calculator because this software missing some parts. So you go on and you go to mod and you scroll down till you find stat diagnostics and you go on. I don't have it here on my screen because it's some sort of a virtual program. And you can find it on this screen. So once you go down and you make stat diagnostics on, your calculator can calculate your value of R. You go to stat again and to calc after filling the list. Let me fill the list just. So after you fill the lists and you go to linear regression, you put list 1 and the y values in list 1, you press enter. After turning the diagnostics on, you'll find the value of R squared and R, but I need to find the value of only R. So the answer to BI, I'll find that R is equal to 0.997, which is a positive. Here it means I'm having a strong positive correlation. Let's go to B section double I. State which two of the following describe the correlation between the variables. We have to pick two. It is a strong correlation, and since my sign is positive, it is a strong and positive correlation. If you have a Texas Instrument, you have it in front of you, it's really easy because it's more easy to deal with rather than run my virtual software that appears on my screen. So now we found the value of R. We made a comment on the value of R. We find the line of regression. And why did we find the line of regression? Is for prediction purposes. And then at the end of each class, I have to remind you to keep practicing, practicing, and practicing.